Alright dear children, let's do next numerical problem, that is problem number 3. And problem number 3 says that a parallel beam of monochromatic light of wavelength 500 nanometer, means your wavelength of light is how much? Wavelength is lambda, that is 500 nanometer. This is 500 nanometer. So this is in nanometers, I convert into meters. So it will be 500 into 10 to minus 9 meter, because nanometer means the power of 10 to minus 9. Okay, so I can write this as 5 into 10 to minus 7 meter. So what is the wavelength of light which is incident on the slit? 5 into minus 7 meter. It's incident normally on a rectangular slit. Okay, and question said that the angular width of center maximum in front of a diffraction is found to be 60 degree. Means out here the angular diffraction is given. That means your angular diffraction. Okay, let me write down angular what? Diffraction. Okay, means the angular width, the angular width is given. The angular width of central maximum is given. Central maximum, which is 2 theta 1 is given, that is 60 degree. So 2 theta 1 is basically the angular width of central maximum, and which is 60 degree. This is given. Now what actually we need to find out? Find the width of slit in meter. So we have to calculate the width of the slit. And children, you know width of the slit we basically symbolize better E. So we write down E be the width of the slit. Let E be the width of the what? Slit. So if E be the width of this rectangular slit, then we can use the formula of center maximum, angular width of center maximum. And you know the formula is 2 theta 1 equals to 2 sine inverse lambda by what? E. So this is the formula that measures the angular width of center maximum. But this formula which we use is measured in degree. That's why your angle is degree. That's why we use this formula. Now 2 theta 1 is 60 degree. So 2 theta 1 is 60 degree equals to 2 sine inverse lambda by what? E. Now this 2 will divide to 60. So how much degree? It will be 30 degree. Okay, which means the 30 degree equals to sine inverse lambda by what? E. Now I take this minus sine inverse on the left hand side. It will be how much? Sine 30 degree. So if I take sine inverse left hand side, it will sine 30 degree equals to lambda by what? E. And children, you know what is the value of sine 30 degree? 1 by 2 equals to lambda by E. So let me just do the cross multiplication. Let me just cross multiply. 1 into E means E, 2 into lambda. 2 into what? Lambda. Now 2 into lambda, your wavelength is how much? 5 into 10 to the minus what? 7 meter. 2 5 is how much? 10 into 10 to the minus 7 meter. Now 2 to the power how much? 10 into minus 7 meter means with power, this power 1 means this is 1 into 10 power minus 6 meter. So 1 minus 7 is 6. So how much? 1 into minus 6 meter. So this is actually the value of E. E means the width of the slit. So what is the width of the slit? E equals to 1 into 10 minus 6 meter. So this is the width of the rectangular slit. So this is the explanation of problem number 3. Now we do the last problem. That is problem number 4, and with that numerical problem 4, a chapter diffraction unit get completed. Now problem number 4 says that, okay, this is problem number 4, and problem number 4 says that a slit of width E. So what is the width of the slit? E is illuminated by a red light of wavelength, how much? 650 nanometers. So let's do the solution of this question. Okay, the question says that there is a slit whose width is E. So I write down the width of the slit. Okay, so I write down the width of the slit is E. Is illuminated by red light of wavelength. So light of wavelength is given. Lambda means how much? 650 nanometer. So what is the wavelength of red light? 650 nanometer. So I convert this into meter. So it means 650 into 10 minus 9 meters. So because even your wavelength is nanometer, and you know nanometer order means 10 minus 9 meter. Okay, the first diffraction minimum First diffraction minimum means the first secondary minimum is observed at an angle theta 1. That angle is theta 1 at how much degree? 5.2 degree from the direction of incident beam. That means what is theta 1? So 5.2 degree is the angle of diffraction. Angle of what? Let me write it this way. Angle of what? Diffraction for first secondary minimum. First secondary what? Minimum. So this angle which is given, that is theta 1 is 5.2 degree. Now what actually we need to find in this question is calculate the width of the slit. The width of the slit means this E only we have to find out, but in millimeter. And also we need to calculate theta 2, the angle theta 2 at which the secondary minimum, second secondary minimum is observed. And after that, what is the angular width of center maximum? So at the same time we need to calculate the angular width of center maximum also. Now in order to solve this question, I use this condition, and I don't change for first secondary minimum. For first secondary what? Minimum. You know, for first secondary minimum, the condition is E sin theta 1 equals to what? Lambda. E sin theta 1 equals to lambda. So from here we have to find E. So E equals to lambda by what? Sin theta 1. So if I make E as the subject, from here I'll make E, that is the width of the slit, as in terms of lambda and theta 1. So let me substitute the value. The wavelength is given how much? 650 into 10 to the minus 9 by sine of theta 1. Now theta 1 is how much degree? 5.2 degree. Theta 1 is how much? 5.2 degree. Okay. Now this value of 5.2 degree can be calculated, substituted. Okay. Now it will 650 into 10 to the minus 9 by, now use calculator. See, you are allowed to use calculator. Use calculator and calculate the value of sine 5.2 degree. You get approximately how much? The value will be 0.0906. Sine 5.2 degree, okay, which is not the standard angle, but if you use calculator and calculate, it will be 0.0906 value. So this is the value of sine 5.2 degree. Now what I do, I remove the decimal. After decimal, 1, 2, 3, 4 numbers. So let me write this way. 650 into 10 to the minus 9 into 10 to the power what? 4 by 960. Okay. Now this can be simplified further. Okay. Now if I simplify this quantity further, okay, so I can write the expression now as it will be how much? Expressed as 65 into 10 power. Now 0 1 0 means 10, 1 plus 4 is 5. 5 minus 9 means minus 4 by 906. Now 65 divided by 906, if you use calculator and divide, you get 0.017. So 65 by 906, if you divide 0.0717, okay, 17, and into 10 power what? There is a power minus 4. So look at it. This division is 0.0717 and there is already 10 minus 4. Now if I calculate this value E in millimeter, this is in meter, so the power should be 10 to minus 3. So what I do this way, 0.00717 into 10 minus 3 meter. And you know 10 to the minus 3 meter means 1 millimeter. So children, let me just do this side also. So E equals to, if you write the answer in millimeter, so it will be 0.00717 millimeter. But we calculate this value in meter only. In what? Meter. So there is 0.0717 into minus 4. So if I shift the decimal, so let me just do the continuation. This one, 0.0717 into 10 to the minus 4. Now I'll make this, I shift this decimal to 2 number right. If I shift this decimal to 2 number right, and if there is a negative power, means power increased by 2. So it will be 7.17 into 10 to the minus what? 6 meter. So we can write this way also, children. So E equals to 7.17 into minus 6 meter, or you can write this in micrometer. So E equals to 7.17 micrometer. So you can write the answer in any of the unit. In meter, this is the value. In micrometer, this is the value 7.17 micrometer. In millimeter, if you write, then this is the value 0.00717 millimeter. So this is the solution of first part of this question. Now after that, what we need to calculate? Okay, that you need to calculate at what angle theta2 the secondary minimum is observed. So we have to find the angle made by the first secondary minimum. Sorry, we need to calculate for second secondary minimum, children. Okay, so for second secondary minimum, there is a condition E sin theta 2 equals to 2 lambda. The path reference for second secondary minimum is E sin theta 2 equals to 2 lambda. Now this angle we need to find out. So I write down sin theta 2 equals to 2 lambda by E. Okay, 2 lambda by E. So let me just do the calculation. Now it will be 2 into lambda. As you know, value of lambda is how much? 650. Okay, into 10 minus 9. The value of lambda is this much by E. The value of E we have calculated already. That is 7.17 into 10 minus what? 6. Okay. Now we can do the calculation. So in this case, if I take this power in the numerator, it will be how much? So 2 into 65 means 113 into 0. So there is already 0. So means 2 into 650 means 1300 into 10 power minus 9 minus 6 if I take in the numerator plus 6 by 7.17. Now 300, this quantity can be divided. It will be 113 into 10 minus 6 plus 3 means minus 9 plus 6 means minus 3 plus 2 means minus 1 by 7.17. So if you divide and do the calculation, you get as 0.1813. So children, you do it this way: 113 by 7.17 into what? 10. This 10 will go in the denominator. So then multiply, you get the value 0.1813, and this is sin theta 2. So this is sin theta 2, but we have to calculate theta 2. So on the right hand side, it will be sin inverse 0.1813. Okay, so if you use calculator and calculate sin inverse 0.1813, your angle will be how much? Exactly equals to how much? 10.4 degree. So how much degree you will get? 10.4 degree. So this is the angle made by the second secondary minimum with the central maximum. Now children, we calculate now the last part, that is the angle of width of central maximum. The formula is 2 theta 1, and 2 into theta 1 is how much? How much? It is 5 point how much degree? 2 degree. So the multiplication means it is 10.4 degree only. So angle of width of central maximum also how much? 10.4 degree. So I have explained in detail problem number 4 also. Okay, so with this numerical problem 4, your chapter diffraction of light is completed. So we have completed what? Unit 6, the optics, which carries how much? 20 marks for ISC examination. Thank you so much.